As a vector is determined by its direction, its magnitude, and its sense. Represented, let's say vector u. U منه سهم يا رجال. Vector u.
Yes.
This is a vector determined by direction, magnitude, and sense. Direction, it means the line of action or any line parallel to it. The line holding this vector. Any line or the line holding this vector or any line parallel to it. This is the direction. Direction, not like what you study in physics. Direction اللي كنت عم تحكي عنه دانيال مش دانيال ريبال الاتجاه لا. It is direction, it is the line of action or any line parallel to the line of action. When you say sense, sense هو الاتجاه اللي انت عم تحكي عنه. From initial point to the terminal point. Okay? And magnitude, it is the length of this vector. طيب. To represent a vector on the plane, consider any point A in the plane. Any point A in the plane. And draw from point A a vector equal to this vector. A vector equal to this vector. What do you mean by equal vectors? What do you mean by two vectors u and v are equal?
يعني have same direction.
What else?
Same sense and same magnitude also.
Same direction, same sense, and same magnitude. Okay? So from A, you draw a line parallel to vector u. Parallel to this. Okay? And the sense going from, this is the vector u, so from this way or from A to B, because here, of course, you can draw a line in this way. Okay? From A, you can go in this way or in this way, but same sense, so it should be from this way, in this direction. Now, equal magnitude, let's say the length here is 3. You draw here point AB so that AB is equal to 3. Here we draw a vector AB. Vector AB is equal to vector U. They have the same direction means parallel or on the same line, collinear, same magnitude, and same sense. This is the meaning of equal vectors, and this is how to represent vector in the plane through or from a point A. Okay. Now, how many vectors equal to a vector U? How many vectors can you draw equal to vector U? We may draw infinite number of vectors equal to vector U. Why? Because if you consider any point in the plane, from this point you can draw a vector equal to a vector U. Same direction, same magnitude, and same sense from any point in the plane. Good. Now, zero vector. What is a zero vector? Vector, zero vector, we write zero from a vector, and please differentiate between two things. Zero and zero vector, zero and zero vector. Here, zero it is a number. When you write vector, it is a vector quantity. Here, numerical quantity, on this one, vector quantity. Just like for the segments, we write, for example, AB. AB, it is the length from A to B. We write line AB, it is the line AB, all the points on the line AB, or segment AB. It is part of the line, which is from point A to point B. And we have vector AB. It is the vector. كل واحدة منهم هي كل واحدة غير عن الثاني. Okay? Like the same idea for zero vector. Differentiate between zero vector and zero. This is numerical quantity. This is vector quantity. Zero vector. What is a zero vector? It is a vector that has a magnitude equal to 0. The magnitude of this vector is equal to 0. And in fact, it is represented by a point. It is represented by a point. It has no magnitude. In this case, direction of zero vector, we don't have any direction. Because you know that if you have vector u, the direction of vector u, it is the line holding vector u or any line parallel to it. Type through a point, we may draw infinite number of lines passing through this point. So which one is the direction? We don't have any direction. Okay, zero vector. It is a vector. Magnitude of this vector is 0, represented by a point, and it has no direction. Clear? Any questions till now? Do you have any question?
لا أستاذ.
Good. Right. If you have vector AB is equal to vector CD, two vectors A and B, initial point A, terminal point B, and vector CD with initial point C and terminal point D. And these two vectors are equal. What can we deduce? And assume that the points here are not collinear. A, B, C, and D are not collinear. And of course, both are not zero. Zero vector يعتبر
ما هو أستاذ
أهلا مرحبا.
كان النت مش منيح.
عادي. By the way, if you say AB is equal to zero vector, then A and B are confounded. يكون نفس البوينت صح؟ Right?
Yes.
A will be the same point. Right. So you're assuming that these vectors are not zero and assume that the points are not collinear. What can we deduce?
هن parallel.
What else? مين اللي هني parallel?
Vector AB parallel vector CD.
We don't say parallel vectors. We say equal vectors or not equal vectors. But we talk about parallel lines.
اوكي يعني line AB parallel line CD.
Good. AB is parallel to CD for one reason. Because when you say two vectors are equal, it means they have the same direction, same magnitude, and same sense. For the direction, we said that the direction of a vector is a line, any line parallel to the line holding this vector. So these two vectors have the same direction. It means that these two lines are parallel. AB and CD are parallel. Because, and assume here from the beginning I said that AB, CD are not collinear. أنه ممكن يكون عندك هيك A, B, C, D. Here vector AB is equal to vector CD. They are collinear. بقول assume that they are not collinear. نشوف شو بيطلع معنا. طيب. Once you have AB and CD are equal, AB, right, CD, two directions of the same vector, it means that the lines are parallel. AB is a direction, line AB is a direction of vector AB, and line CD is also direction of vector CD. Since these two vectors are equal, then they have the same direction. So AB and CD are direction of the same vector, then they should be parallel. Because as we said, direction of a vector is any line parallel to the line holding this vector. Okay? So here, any line direction vector of line AB, it is of direction vector of vector AB, it is the line AB or any line parallel to it. So, يعني CD is parallel to AB. What else? What else?
They form a parallelogram.
Which one is a parallelogram? Name it.
ABDC.
ABDC is a parallelogram. I'm going to write it here. ABDC is a parallelogram. Can you justify?
Yes.
How?
I guess because AB is equal to CD حتى بالmagnitude لأنه equal vectors.
Here we have the lines are parallel because they have the same direction. These two vectors have same direction, then the lines should be parallel. But the two vectors are equal, it means their magnitudes are also equal. It means that AB as magnitude is equal to CD in magnitude. Then here we will have, according to what you studied in grade 8, this quadrilateral, we have AB is equal to CD and AB is parallel to CD. That means that ABDC is a parallelogram. And be careful here. It's not ABCD is a parallelogram. AB DC is a parallelogram, because here for the sense AB CD AB the sense اللي انت فهمانها الاتجاه from A to B, from C to D. I can't put it CD, AB and this vector have opposite sense. واحد هيك وواحد هيك. They have opposite sense. But here they have the same sense. So if you draw from A to B, you have to draw from C to D. Okay? Then the parallelogram will be AB DC. Okay? So if two vectors are equal, and they are not collinear, points are not collinear, then for sure we have a parallelogram, and the name ABDC is a parallelogram. This is one of the most important notes you have to know. Any question till now? Any question?
No.
Good. And Melissa, she's absent. No. Raji and Rami. And Rita. Okay. So till now, we talked about definition of vector, definition of, or the meaning of two equal vectors. Two vectors are equal, same sense, same direction, same magnitude. Graphical representation of vector. And if you have two vectors are equal, graphically it means that we have a parallelogram in case the points are not collinear. Of course, here you will have one of two things. If if AB is equal to CD, then one of two things. Either we have parallelogram or the points are collinear. Assuming that the points are not collinear, then the quadrilateral will be a parallelogram. Okay? And this is vice versa. It means here, if you have this, then ABCD is a ABDC is a parallelogram. And the opposite. If you have ABDC is a parallelogram, then we will have two pairs of equal vectors. We will have AB is equal to CD, and which two vectors will be also equal?
AC and BD.
AC وBD.
AC and BD will be also equal. Okay? So in any graph, whenever you want to look for equal vectors, search for a parallelogram. Okay, good. Now, addition of two vectors, how to add two vectors. And then chaseless relation. Do you know chaseless relation? Do you have any idea about it? You don't have it.
أساس شو هي؟
Chaseless relation or Chasel's relation. Okay. You don't have any idea about it. Okay, no problem. Now, the sum of two vectors, addition of two vectors. If you have vector u and vector v in the plane, and you need to add these two vectors. Here you have vector u, and let's say we have another vector v, and you need to sum. You need to add to find the sum. Sorry, of u and v. You have to find the sum of u and v. How to find it? U plus v will be also another vector, w. U plus v will be another vector, w. How to draw this vector, w? Or how to find this vector, w? Consider any arbitrary point in the plane. Let's say point O. Any point, from O, you draw a vector, خلينا نسميه OA. OA is equal to vector U. OA is equal to vector U. How to plot point A? From O, you draw a line parallel to the direction of U in the same sense and of same magnitude. This is A. So vector OA is equal to vector U. And now, from this terminal point A, draw another vector equal to vector V. let's say vector AB. AB is equal to vector V. From this point, draw a line parallel to a line of action of this, and in the same sense, same magnitude, not even here. Okay, here point B. Then vector W, it is the vector OB. Initial point, terminal point. This is vector W. W, it is vector OB. So we write vector W is equal to vector U plus vector V. And please here differentiate between two things. Now, the concept of vectors, I can say it's new for you. You have to differentiate between two things. A vector is not only quantity, numerical quantity. It's not only magnitude. It's not only magnitude. هتقول لي مثلا الأستاذ إنه كيف هي ظابطة معك إنه هاي هي قد هاي بلس هاي؟ أكيد لا. هي مظبوط. The numerical values, distance, length of segment. This segment, the length of this segment, of course, it is not equal to the length of this plus the length of this. But for the vectors, moving from O to A and then from A to B, it is just like moving from O to B. This is the addition of vectors. Okay, we are not adding numerical values. And let's say this is 2, this is 3, then this one will be 5. No, it will not be 5. Okay, واضح اللي عم بحكيه؟
Yes.
Good. Now, the choices relation says the following. In case you have vector AB plus vector BC, what will be the answer? You are adding two vectors, AB.
أستاذ هادي مذكر شوي منها.
ايه شو بيطلع؟
يمكن بنعمل اي سي ما بعرف، مذكر شيء بسيط منها.
طيب
بناخد البي كومون يمكن.
It's equal to AC. It's equal to vector AC. Look here. The terminal point of the first vector, initial point of the second vector are equal. Then the sum will be equal to AC. According to the sum of vectors, هلا اللي كنا عم نحكي قبل شوي. Vector U plus vector V is equal to vector W. How to find the sum? We said in order to find U plus V, you start from any point on the plane, from point A, draw a vector equal to, or draw AB as equal to the first vector U, and from B draw a vector, another vector V, BC, it's equal to the given vector, and then the sum will be initial point, terminal point. Here, this W here I drew, it's U plus V. Okay, ولكن احنا كيف ماشيين؟ please انتبهوا لي عليه وهون. From A to B and then from B to C, the answer will be from A to C. This is what we call Chase's relation, written on page 88. Okay, right. You can generalize this, but understand the idea. Inner points are equal. They have the same inner point. Then the sum will be equal to the first, initial, and the terminal. Okay? And here not only sum of two vectors. We may have more than two vectors. Let's say AB. If you have vector AB, plus BC plus CD plus DL plus LI. What will be the sum?
AI, maybe.
It's AI. For one reason. For one reason. If you consider the first two, AB plus BC, what's the answer? Only the first two. According to
AC.
Chester's relation,
AC.
AC, right, plus CD plus DL plus LI. Right. What about these two?
AC.
Equal AD.
AD.
It's AD
AD.
plus. And the same idea here.
Mm.
We have the same inner points, so it is DI,
لا دي I.
which is equal to also
Equal
these two vectors.
AI.
It's AI.
Vector
In other words, initial, terminal, whether we have two vectors or more than two vectors, the same idea. To understand it graphically, as if here I am saying the following: A, B plus B, C plus C, D plus D, L plus L, I, then the sum will be equal from A to I. يعني بلشت من عند ريبال، طلعنا لعند مالينا، فنزلنا لعند لين، رحنا عند ماليسا، كملنا لعند ريبال، ورحنا لعند رامي، كأنه آخر شيء رحنا من هون لعند رامي. That's it. وين بلش؟ وين انتهى؟ Initial point, terminal point. Okay? Is that clear?
Okay.
But here, as I said,
Yes.
be careful that the inner points should be the same. Initial, terminal, AB plus BC, it's equal to AC. هذا الاثنين بيكونوا equal. طيب. Sometimes we don't have equal points or the same point. The palm rule. If you have AB plus AC, what will be the sum? Can we apply Chester's relation here?
تطلع بي سي أستاذ.
No?
No.
Can we apply Chester's relation?
No, we cannot.
We can.
No.
If I'm-
هون في اثنين فينيشيال لأنه
لأنه initial points in نفسه A. What will be the sum? يعني if you have like this AB vector AB, and if you have vector AC, AB plus AC, AB plus AC. But you know,
بدك تعمل بار
oh good, هذه عامل بار. How?
مو equal vectors مو vector equal ل AC from point B وvector
Okay.
equal ل AB from point C
وحدة منهم
والpoint اللي بتطلع جديدة
ما في داعي لاثنينهم.
يعني
So let's say from point C, draw a vector,
okay.
let's say CD. Vector
هيدي
CD.
الpoint AD هي sum of vector.
Good, very nice. Vector CD is equal to vector AD. Okay, then I can say the sum AD plus AC, it is AC or AB, it's CD plus AB plus AC, right?
بتطلع AD.
بتطلع AD لأنه هون نبدلهم AC plus CD. Now don't we have the same initial or the inner points? Initial point or terminal point, initial point, then the sum will be equal to AD. Right. What is point D? We said that point D is a point so that CD is equal to AB. Right. Back to this. If AB is equal to CD, AB is equal to CD, then شو بيكون عندنا؟ هلا قبل شوي حكيناها. If CD is equal to AB,
It's a par.
من هو؟ Name it.
ACD.
A B و D C.
ABDC. إذن هي AB plus AC is equal to AD, where D, بالأساس we don't have D. بس أنا في سميه where D is the fourth vertex of the par A AB مش بكمل CD AB DC. هيك كيف بكتبهم AB بعد عندي A هون صح؟ بعد في عندي 2 points C and D. AB البوينت الجديدة دي مع C AB DC. Okay, so you have AB plus AC. In fact, here the sum will be this diagonal. AB plus AC, we got AD. That means the diagonal of the par. Graphically, to represent this vector to the diagonal. This is what we call the par rule. Do you know it from grade 9? جاد
أستاذ.
grade 9.
هلا اتذكرتها.
The par rule. Okay. Good. Any questions so far?
لا أستاذ.
نعم.
No لا.
So equal vectors. That means they have the same direction, same sense, same magnitude. 2. Zero vector. It is a vector with zero magnitude, represented by a point. If you have two vectors in the plane AB and CD are equal, then we have a parallelogram ABDC. The sum of two vectors, traceless relation, we have AB plus BC is equal to AC. These two initial point, terminal point, initial point. And in case you have the same initial point, AB طلعوا فيهم هيك حتى تحفظوهم بطريقة وتفهموهم بطريقة أسلس. You have AB, AC, AB. The same initial point, A and A. AB plus AC, it is the diagonal. خلاص انت يعني بس تشوفها بشي فيجر، اوكي؟ بس تشوفها بشي فيجر قدامك. AB AC يعني بتكمل AD هذا diagonal بده يكون هون في عندك diagonal وباراليلوجرام. اوكي؟ clear؟
Yes
أستاذ بديع ما عنده إنترنت.
بديع ما عنده انترنت.
Yes.
ثلاثة ورجع طلع.
طلعت بالغلط.
مش بس انت بحكي عن بديع كمان. بديع طلع. بعد في حدا كمان طلع. دانيال موجود. ايفا ريان طلع. Okay. Good. From this, we can do the following. Using this idea, we can do the following. Sometimes we use it just to state it as a remark, similar to the projections in the plane. Here we said that AB plus AC, it is equal to AD. AB plus AC is equal to AD. Yep, we can do the opposite. If you have AD, using this simple idea, if you have, for example, vector A, D, or vector AB شو بدك if you have two lines intersecting lines at A شو بدك شو ما يكون وين then I can say that vector AB from point B draw a line parallel to the first one هنسميهم D1 and D2 from point B draw a
يا
line
أستاذ مجرد.
أهلا from point B draw a line parallel to D2 and draw a line parallel to D1 يعني like this. Okay. These two lines intersect D1 and D2 at 2 points سميهم بدك AM or M and N. Now I can break down this vector AB into two vectors which are AM and AM. Okay. هاي إذا بدك مثل تشبه projections. Okay. إنه أنا في أقسم هذا الفكتور لشكل two vectors projection on line D1 projection on line D2 but of course not orthogonal projection. Okay. Vector AB it is AM plus AM. Sometimes you use it later on especially in physics كمان بتستعملوه. اوكي لا راح نشوفها كمان بعدين بالcoordinate system. By the way الفيكتورز يعني هلا بلشت معنا قصه طويله. يعني هلا عندك 6 lessons فيهم فيكتورز. مش انتبه مش هتخوفك عم بقول لك صعبين لا بس لك انه قديش هذا الفيكتور مهم. لاني مش امور منا كثير صعبه لا عاديه. الواحد بيسلس فيها طبيعي ما في مشكله. كيف بس انه عم بقول لك انه توبيك كثير مهم. عندك 6 lessons ماشيين فيهم بالفيكتورز. Now for the opposite vectors, negative. Two vectors, U and V, are